All right, hello everyone and welcome. Today, we are looking at something absolutely crucial. We're going to dive headfirst into some of the most cutting-edge and, honestly, sometimes terrifying scientific data from 2025 and 2026 to figure out exactly how our planet's engine actually works. You know, we hear terms like climate system thrown around constantly, but in this explainer, we're literally popping the hood and looking at the mechanics for ourselves. Think of this as our user manual for Spaceship Earth. We're going to keep it moving and cover the planetary machine, Earth's energy balance, amplifiers and feedbacks, cascading tipping points, extreme impacts, and finally, restoring the balance.
Okay, part 1, the planetary machine. Before we get into the heavy gears of this machine, we really need to shatter a very common illusion. So let's dive into this. Weather is simply what's happening outside your window right now on a Tuesday morning. It's the rain, the wind, a sudden temperature drop. Climate, on the other hand, is a statistical average. It's usually measured over a standard 30-year period, and it represents the entire state of an incredibly complex, deeply interconnected system. So the crucial point here is that the climate system isn't just the air floating above our heads. It's a massive, dynamic engine. It's powered by sunlight, its temperature gets modulated by atmospheric gases, and then all that energy is constantly redistributed across the globe by ocean currents and winds. The whole shebang is controlled by how heat is stored and how that energy flows.
And this engine basically stands on 5 major interconnected pillars. First, you've got the atmosphere. That's the fast-responding, thin gas envelope where our daily weather happens. Second is the hydrosphere, which is mostly our oceans. And get this, the oceans actually absorb the vast majority of the planet's heat. Third, we have the cryosphere, our ice and permafrost acting as a giant planetary mirror or reflector. Fourth is the lithosphere, the rocky crust that influences climate over long periods through things like plate tectonics. And finally, the biosphere. That's all living things and ecosystems driving the carbon cycle. The big takeaway? If you tweak any single one of these components, the ripple effects spread across the entire globe.
Moving on to Section 2, Earth's energy balance. This energy balance is the absolute core mechanic of our climate. If you understand the energy coming in versus the energy going out, you fundamentally understand climate change. It's really that simple. Check out the scale of this. Our atmosphere is about 78% nitrogen and 21% oxygen. Those are the massive players. But it is that tiny 1% slice, the trace and greenhouse gases, that entirely dominates the climate's ability to trap heat. Just a fraction of a percent dictates the temperature of the entire world. Wild, right?
So here's how that 1% actually works. Energy comes blasting in from the sun as shortwave visible light. Globally, that averages out to about 340 watts per square meter. It hits the Earth, warms the surface up, and then the Earth re-emits that energy back towards space as long-wave infrared radiation, which is basically just heat. Now those greenhouse gases, they trap some of this outgoing heat. It's an absolutely amazing natural mechanism. Without it, Earth would be a freezing negative 18 degrees Celsius, literally an ice ball. But with it, we enjoy a cozy, life-sustaining average of positive 15 degrees Celsius.
But let's look at what happens when we humans artificially pump up those gases. The scale of these main drivers is staggering. Carbon dioxide is our baseline. It persists in the atmosphere for hundreds, even thousands of years. That means what we emit today is locked in for millennia. But look closely at methane. Even though it only hangs around for about 12 years, it is 80 times more potent at trapping heat over a 20-year period compared to CO2. 80 times. And nitrous oxide, which largely comes from synthetic fertilizers, is an unbelievable 273 times more potent than CO2.
Section 3, amplifiers and feedback loops.
Okay, now that we know how the energy balance works, we have to look at how the Earth reacts when that balance is thrown out of whack. The crucial distinction to make here is between a forcing and a feedback. Radiative forcings are the initial push, like human greenhouse gas emissions actively shoving the system out of balance. Feedbacks, though, are the Earth's reaction to that shove. A classic example is the ice albedo effect. As the planet warms, highly reflective white ice melts away. That exposes the dark, heat-absorbing ocean water underneath. And because that darker ocean absorbs way more heat, it melts even more ice, which exposes even more dark water. It acts as a massive, unstoppable planetary amplifier.
Which brings us to Section 4, cascading tipping points.
I want you to brace yourselves for a second, because we're going to objectively look at some newly confirmed cutting-edge data from 2025 and 2026. 422. That is the concentration of carbon dioxide in parts per million that we hit in 2024. Just to put that raw, frankly astonishing reality in perspective, This is the highest level of CO2 our atmosphere has seen in roughly 2 million years. Let that sink in. We have completely fundamentally rewritten the chemistry of the sky.
And here is a metric from the latest data that hits even harder. Earth's energy imbalance has more than doubled. Our oceans are currently absorbing an unthinkable 18 times our annual global human energy use. And that's not just once, that's every single year for the past 2 decades. The ocean is literally taking the brunt of this excess heat to protect the surface world, but its capacity is being pushed to the absolute limit. Let's move to and see how this builds into what scientists call a tipping cascade. Back in February 2026, the Potsdam Institute ran millions of simulations, and they found a terrifying mathematical domino effect. Step 1, the Greenland ice sheet melts, pouring tons of fresh water into the ocean. Step 2, that fresh water weakens the AMOC, a really critical Atlantic Ocean current. Step 3, because the ocean current changes, global rainfall patterns shift, which causes the Amazon rainforest to dry out and start releasing its stored carbon. Step 4, that extra warming from the Amazon thaws the Arctic permafrost, releasing massive amounts of methane. One failing part mathematically triggers the next. It creates a cascade, even if we stay under 2 degrees Celsius of warming.
Section 5. Extreme impacts and weather.
We're transitioning now from the deep underlying mechanics of the planetary engine to the physical symptoms we are actively feeling on the surface. Notice how fundamentally our baseline is shifted here. In 2025, we were actually in a La Niña pattern. Now, traditionally, La Niña cools the global climate. Yet, the background warming was so profound that 90% of the entire global ocean surface suffered at least one marine heat wave. No cooling effect could hide it. This resulted in massive coral reef bleaching and provided hypercharged fuel for some incredibly intense cyclones.
Following the data chronologically really grounds the urgency of this science. Look at this acceleration. In 2021, studies confirmed that the AMOC ocean current was at its weakest state in 1,600 years. Then, 2024 was officially verified globally as the warmest year on record. In 2025, that massive Earth energy imbalance we just talked about became so severe it was officially added as a core climate indicator. And by 2026, researchers confirmed our land carbon sinks are weakening, while multiple critical tipping systems are closer to destabilization than anyone ever thought possible. The acceleration is undeniable.
Finally, Section 6. Restoring the balance.
We are going to pivot here, because while all that data is undeniably sobering, the truly empowering reality is that we know exactly which levers to pull to fix this engine. It all comes down to 4 actionable pillars. First, mitigation. This means transitioning our energy grids, and the incredible economic reality today is that solar and wind are actually the cheapest new electricity sources in most of the world, a real game changer. Second, electrification, taking that newly clean grid and plugging our cars and heavy industry directly into it. Third, carbon removal, using both nature, like planting forests, and cutting-edge tech, like direct air capture, to pull legacy carbon right out of the sky. And fourth, adaptation, upgrading our water management and infrastructure to handle the locked-in impacts we simply can no longer avoid.
The current state of our trajectory was summarized impartially, yet with immense gravity, in a February 2026 paper by William Ripple and his colleagues. They stated very clearly, we are seeing an acceleration of warming pointing to a loss of planetary resilience. The machine folks is struggling to self-correct. Which leaves us with one final, deeply provocative question. What will we do with the remaining fractions of a degree? The science is absolutely clear that every single fraction of a degree of warming we avoid directly reduces the risk of crossing those dangerous tipping points. You now have the user manual for Spaceship Earth. Understanding how this incredible machine works is the crucial first step. The next step, well, that's choosing to restore the balance. Thank you so much for joining me for this explainer. Keep learning, and I'll see you next time.